Hello, everybody, and welcome to this month's CISL seminar. Thank you for joining us. Today's speaker is going to be Dr. Robert Redmon. He's a senior scientist with NOAA's National Center for Environmental Information, where he serves as a lead for both the NOAA Center for Artificial Intelligence, or NCAI, and the Space Weather Follow-on Science Center. And Rob, I apologize, I did not have time to query you for more detail, like, doctor from where, where'd you go to school, that kind of thing. So feel free to fill us in on that. In any case, we look forward to hearing your talk. The audience members are on a streaming thing. They will be submitting their questions in writing, and at the end, we'll read them out. So thanks for joining, and Rob, thanks for giving the seminar.
Great, thank you so much. I'm assuming you can all hear me and see me well as my slides. I have the fortunate honor of having had a chance to complete my doctorate at CU Boulder, a lovely place, and having lived here for the last 20 years as well. Really, our entire family is passionate about the Rockies. So thank you so much for this really amazing opportunity. As Jeff summarized already, I work for NOAA, the National Oceanic and Atmospheric Administration. I lead our new Center for Artificial Intelligence. And I hope you enjoy this summary of our activities and plans to share and infuse AI wisdom across NOAA and with our partners. I also look forward to a healthy Q&A and meeting anybody interested at an upcoming professional meeting. So we'll just get going here now. So, all right, so what's the agenda look like? All right, so we'll give you a brief background on what motivates us to establish a Center for AI, and we'll share with you a summary of our activities and plans. I've made this deck about 30 slides, so I'm hopeful that we'll have lots of time to chat if there are any questions. Let's dwell on this one for a second. Think of these numerous really unfortunate, greater than $1 billion natural disasters per year, along with climate-driven impacts to our coastal and ocean ecosystems and food stores as our underpinning motivation for harnessing emerging technologies, such as data, cloud, omics, uncrewed systems, artificial intelligence, citizen science, as a way of doing our part to tackle the climate crisis at home and abroad with socially and environmentally just outcomes. And on a personal note, my community is Louisville, Colorado, and that was unfortunately, alongside Superior, devastated by fire this year. My family and most of our friends are just fine and okay, but it's a close-knit place, like so many of our communities, I'm sure like yours as well. And many in our community have lost everything. And like any community, they're going to be recovering for a very long time. So the great data deluge, as sometimes this is often called, we're really on the precipice of an exponential growth in observing system and modeling capabilities. This curve here is the curve of expected inbound environmental observations, and it's very steep and wonderful. And that, that's from stations, model, radar, uncrewed systems, acoustics, all sorts of techniques, additional satellite sources. And you just think about the Internet of Things and all of the low-cost deployables really coming to market, GoPros on surfboards and things like that. We're really facing a wonderful opportunity, but also a grand challenge to harness all that information, to save it and steward it and curate it, make it AI ready for posterity. All right, so as we know, AI is a proven, let me make this run. There we go. AI is a proven technology for NOAA operations and applications. For example, saving and protecting crucial resources by automatically detecting and tracking marine life, saving human lives by detecting rip currents, as shown in this movie, using coastal web cameras. And I'll dwell on that one for a second. We lost one of our very dear colleagues a couple of years ago, Bill LaPenta, to Rip Current. And just recently, we've internally discussed, hey, this is a really amazing technology. How might we reuse it for other things, like perhaps detecting coastal monk seals and other critically endangered populations? So, obviously AI can be used to harness currently unleveraged observations and take advantage of the great data deluge. Really, we're really excited about this, and inside NOAA, and also with all of our collaborations with NCAR and others. All right, wait for this, get another movie to go here. Let's see, there we go. Okay, yes, who doesn't want to know where the sharks are? All right, this one kind of frightens me, to be honest, a little bit. All right, we all know that the rapid expansion of both increasingly capable instrument suites, as well as low cost, deployable observing systems, like small satellites to low Earth orbit, sail drones in a turbulent sea, great movie about that one, by the way, and GoPro cameras like on surfboards. This has led to an explosion of data-rich opportunities that we have yet to leverage. So think about that, vast potential for uncrewed systems and citizen science observations too, and how to make those complex measurements in terms of their quality and their provenance, bring them into new research and new products. And for example, this one here, as I mentioned on the previous, consider all the different technology transfer opportunities for high rate video feature detection to other ecosystem needs. And this one in particular is Diame. And when I share the slides at the end of the after this presentation, I'll make sure you have all the links to these wonderful things. So what's our background? What are the what are our key underpinnings? We have a new National AI Initiative Act of 2020. We have a signed AI strategy and strategic plan, and we have some synergy around all of those things I mentioned, the NOAA science and technology focus areas like cloud and data, uncrewed systems, omics, etc. Our goals here for the NOAA Center for AI are efficient governance, advancing AI research and into operations, so research to its targeted endpoint, developing partnerships, and training the workforce for development and management purposes as well. Each year, we conduct a study of AI projects across NOAA. So in that tiny graphic on the right side there, if you were to decompose the research to operations plot here, you'd see that our scientists, forecasters, partnerships, and decision-making stakeholders really have already multi-decadal vast experience building and leveraging AI-powered applications. We've been doing it for a long time, and probably working with you. For things like weather forecasting, ocean exploration, ecosystem assessments, and many other applications. So what are we thinking here? We're really looking to kind of harness that distributed brilliance and foster an emergence of communities of practice. So basically combining the knowledge across the communities of practice already there, several in fisheries, for impactful and trusted infusion of AI at NOAA in kind of a standardized way. You can learn more here if you open your browser to NOAA's Science Council portal. Let's see. Okay, so, and if you did do that, you would find all those strategies right there on the right-hand side, covering those key technology focus areas. So for several, we have kind of these cross technology synergistic goals, and also we have planned actions. For AI, saying it kind of again, it's efficient organization and process to align with that congressional authorization that I mentioned, called the National AI Initiative Act. You can go to OSTP to learn more about that. And our new authorization for NCAI, it says within the act that, as on the previous slide, that NOAA will create a Center for AI. Also to advance AI research and innovation that supports our sun to mud mission areas, and thus priming the research to operations pipeline all the way through. And we want to accelerate that pipeline to deploy solutions and applications to support all the different areas that we support. And we can't do this if we aren't building along the way robust commercial, academic, and government partnerships, and also partnerships with the community, with those those end users. We think about social, environmental, equity, and justice, for example. We need to be building those partnerships all through. They all need to be kind of at the seat, at the table, if you will, as applications are thought about. And then, of course, the last, but one very near and dear to my heart, to enable our entire workforce from technology engineers and scientists to senior management to all brilliantly leverage AI. And if it's a proven application that we want to use for a long time, make sure that we're maintaining it and sustaining it and making it better over the years as we see new phenomena in the environment. So here's we're kind of digging in, kind of peeling the onion back. We're going into NCAI now. So how can you connect with us? There's a website, NOAA.gov/AI. I think you can also spell out artificial intelligence, and that works fine too. And you'll find it's our starting point. We deployed that public platform late last year, actually just in time for our last workshop in September. You can join our mailing list. We have about 530 or so members around the world. So that includes government, it includes academia, it includes industry, general public, et cetera. And we're also working on a sticker. We're hoping to bring that to the ESIP meeting in Pittsburgh to share with others who would like to have one. Lots of ways to connect with us. You can also just send me an email. You can send also an emails to ncai.team@noaa.gov, and that'll be also reprinted on the last slide too. Okay, so here's our team today. We've cultivated a pretty diverse cross-NOAA development team, realizing some initial capabilities of NCAI. We've been focusing on solid communications, developing initial training pedagogies and frameworks, really leading a path for NOAA on AI-ready data. I'll tell you a lot more about that. That is through a wonderful collaboration with ESIP, as well as conducting workshops and developing future strategy too. And on the right side here, you'll see this is basically a 2-pager, and you can get a copy on our website. And this talks about a survey that the training development team conducted about a year ago, and this is their analysis. But we'll say more about that in just a few minutes. So what does it look like for us to, if we were to decompose what our activities look like right now? What are we focusing on? What are we doing now as we emerge in our first couple of years towards something fully capable for many years at NOAA? So this is our current status. We have pilot project funding this year, and we have an intention to expand those pilots and initiatives into the future. This year we have 7 projects that I'm really excited to tell you about today in the next several slides. They align across several key mission areas in NOAA. Our NCAI distributed office, not brick and mortar. This supports things like leading the path on AI-ready data development, conducting workshops, and other coordination activities. And everything we're doing links to, sorry for the acronym here, I'll try to expand all of them in real time. Everything we do links to different NOAA high-level strategic focus areas like the Weather, Water, Climate Board, WWCB. So this what we're doing has direct linkages to the WWCB societal challenges, Obviously, it links to the strategy I told you about that's public on the Science Council website. And just to, you can see what the categories here are. I've mentioned a few several times, but just to do it once more. AI-ready data, research to application. So that's exploring the research path all the way through to an endpoint where users can use it. Could be out to commerce, it could be used internally, wherever that right endpoint is. In order to even have that pipeline, we are also seeking to invest in advancing AI research itself. And then the fourth one down is really looking at all the different development that's already ongoing in the community as well as at NOAA, and thinking about how can we leverage similar software needs to build packages that are modular and sustainable and usable by many different use cases. All right, really excited to tell you more now about our pilot project. So just want to give you a perspective of a roadmap here. This year, we are getting our feet wet on resourcing the coordination of AI at a corporate level, because as I mentioned, there are already hundreds of AI projects going on at NOAA, and NOAA has been investing at the project level for many years, always seeking to use the best of data science, of course. And so this is about coordinating some of those activities for greater good to share with each other. All right, so on the getting our feet wet, getting our feet wet topic here, this is a list of our pilot projects and initiatives that we're pursuing right now. Developing AIReady Data Standard, mentioned that, so it's collaboration with ESIP, and this is all about defining what does it mean to be AI ready and uplifting sample data. Mentioned developing training tools and frameworks and ways of thinking about how to train ourselves and our workforce, including partnerships with NASA, the NSF AI Institute AI2ES, and creating some initial capabilities, like think of sandboxes that are Jupyter notebooks that connect NOAA data and machine learning techniques that people have tried and succeeded at. Then we have some pilots creating a training data set for tropical cyclones. I'll tell you a little more in just a second, have a full summary on that one. Valuing NOAA's data with publications, connecting the dots basically between the peer-reviewed publication repositories and the source data they've used. Towards fusing environmental and social data, this one's going to be about homogenizing a humidity data set. And then, of course, making sure we're conducting workshops that are really engaging. And that's what we're going to talk about, all of those things right now. So let's get right into it. All right, so let's talk about data ready let's talk about getting data ready for AI applications. It's pretty obvious probably, but still it's always worth thinking about. Key to any training or AI development activities is having high quality AI ready data. A foundational touchstone of any such development is leveraging observations and model data that are already wrangled, massaged, etc., processed, and made ready for your AI applications. So in that sense, we are collaborating with the Earth Science Information Partners, ESIP, if you haven't already worked with them, wonderful group, through a data readiness cluster to develop a standard for AI ready data. A synopsis of what the community has said they need includes a formal standard to be developed and approved upon, tools for data creators and stewards to assess the repositories, and a way to represent the degree of AI readiness. For example, think about the question, is the metadata itself machine actionable, or is it unstructured information? Are these data feature labeled? And what is their quality? Is the data reusable as a training data set for other machine learning model development? All right, sneak peek. Almost half of the ESIP AI Ready Data survey respondents spend at least half of their time on data preparations before they can get to work on the science questions they're trying to answer. I think that is resonant throughout our community, the amount of time we spend data wrangling. I need to find the source of that original quote because this is empirical. This is an empirical validation of that. Okay, so the what, the why, the what, and the how. Key, so we already said key to any development activity is having high quality AIReady data, and that's a foundational touchstone for getting started even. And here's the synopsis. They've said they need a community developed and driven definition. It needs to be living, so it's updated over time. It needs to be updated with feedback, updated based on new and emerging data sets. We need a way to represent readiness level, and digging into that in a nuanced way. We can't give one score to each data set. It really needs to be readiness for the use case, and that's so that providers can that report that data readiness within their supporting organization, and also to users, so that users can pre-plan maybe the level of effort they will need, and also so that providers can as they curate these data sets over time, can can strengthen their arguments and business cases for the resources they need to do so. It's iterative, and ideally, I should just say it does need to eventually be a formally published standard, or maybe set of standards. All right, so there's a link there to the data readiness cluster. There is a monthly meeting. It is being chaired by Douglas Rao, who hopefully you all got a chance to hear from a few weeks ago in this same seminar series. And if you didn't, I think it's recorded, so you can go and check that out. It's a great talk. And from the NOAA side, it's being co-led by Douglas Rao and Stacy Robinson, and in the past, Tyler Christensen, who you've probably met as well. So here's I already sneaked the message, I guess. So, but just to say it again, a survey was conducted in the winter, and almost half of the respondents spend at least half of their time on data wrangling, or maybe another way to look at this is, less than 20% or so spend less than 25% of their time. So it's not very many. And so a lot of us, as we know, do have to spend a lot of our time getting things ready. Our goal is to work to minimize that for everybody's benefit. All right, so digging deeper. What is readiness? So readiness is a combination of factors. And again, an entire seminar was dedicated a few weeks ago to this topic by Douglas Rao. It's a brilliant seminar. Please go check that out. I'm just going to give you some of the highlights of the activities. All right, so readiness is a combination of factors in three areas: data quality, access methods, documentation, and data preparation. I should have said 4 areas for AI usage. A few initial findings driving the development of a standard include consistently formatted files. A lot of this is going to make total sense. So we're preaching to the choir here. So consistently formatted files, especially data sets that span long periods of time and space. We need a variety of access points, including cloud optimized access. We need sample working code and Jupyter notebooks or other interactive code with visualization. And these are going to demonstrate how to use these data in AI applications. We're going to talk more about that because it's one of our primary focus areas. We also need labeled features for use in model training. Working with ESIP, we had a survey that was conducted to understand the requirements are needed for open environmental data to enable AI applications. And we'll basically continue to tell the ESIP data readiness cluster about your needs by perhaps joining a cluster meeting, and also sneak peek advertisement, maybe attend the July ESIP meeting where we are conducting a follow-on session there. Ideally attending the ESIP meeting in person if you can, but if not, I think we will do our best to support virtual attendees as well. Okay, so a few more findings, and then we'll go on to the next topic. There were about 104 responses, mostly USG and academia, to include some non-governmental organizations, and at least 10% or so from private industry. Always looking for more inputs into that process. So again, engage with the cluster if you have an interest. The key things were things like outliers are included and tagged, gridded in space and time, targets are labeled. On documentation, we need metadata with details about all the parameters. Again, example code with notebooks and information about space-time extent. On data quality, it's all about consistency, completeness, resolution, and lack of bias. On access, again, multiple access methodologies are really important. Things like cloud, the ability to download files to your local environment, and APIs. These were kind of evenly split, so it just shows that there's a lot of different kinds of users. On training data reuse, at least half published their training data, which is pretty awesome, and we'll look forward to those numbers going up. And 50% used training data from another group, also pretty awesome number, and we're looking forward to that going up. Think about the formats that you can work with for AI, ML, and data science needs. Obviously, they should be self-describing. Text formats were also considered good, and some people preferred cloud optimized. And a majority did say they could handle 4 or more formats, which I think is testimony to the maturity of our communities and the application programming tools that are available. So what does our roadmap look like on this topic, AI-ready standard development? So I mentioned that the survey was conducted by ESIP, and a session on initial results was held in the January meeting. Survey results have now made it to a draft standard. There's a little screenshot for you there on the left side, as well as a link to it. It's always evolving, so best way to have the latest, again, is to check in with the data readiness cluster. What's upcoming? We're looking forward to working with the community to assess sample open data sets, in particular climate, for the upcoming ESIP session. There's the July session mentioned there. There's a link there to join and register. Thereafter, we're looking towards assigning readiness levels, different kinds for use cases, and to develop improvement plans for, or at least make that available, make that a possibility, right? All along the path, we need to do reality checks with key users, and we need to use that feedback to improve the draft standard. That was really highly resonant. The standard will need to live with the live and be improved iteratively based on feedback received, as well as new technologies and new techniques emerge. And we are already including this kind of information within NOAA opportunities. Okay, so there's the final and complete shout out to the ESIP meeting in July. The title is Enabling AI Application for Climate, Developing a Collection of AI-Ready Open Climate Data. It's a data-a-thon. Really love these a-thons, like hackathons and trust-a-thons. The session purpose: initiate a community collaboration on the development of a pilot thematic AI-ready catalog of open climate data sets. The intended outcomes and goals are to build a group of active contributors to develop a pilot thematic AI-ready open climate data set or data sets, to assess the readiness of a selection of open climate data sets for AI applications, and to design a catalog framework for representing those AI-ready data collections. So please join the session, or please register, join the session, and bring your climate data sets of interest if you're interested in this. So we're going to go to the training initiative topic now. And I'd like you, throughout this whole seminar, I really love the opportunity here to give you a summary of what we're up to. We're always looking to build partnerships. So please be thinking about any collaboration opportunities that come to mind throughout any of the topics mentioned in this talk. All right, so what are we up to? We're supporting the trustworthy AI application for environmental science Trustathon Summer School in June. This is a collaboration between NCAR and the NSF AI Institute, AI2ES. Again, we're always learning of new opportunities. I just recently learned about Project Pythia, if I've pronounced that correct, as part of Pangeo. So I'd love to learn some more if you have other ideas too. So I mentioned kind of earlier in the talk, and now we can dig into it a little bit more. Last year, we conducted a survey across NOAA on the needs of our staff. So we've conducted a few surveys inside NOAA. Every year, we conduct a self-assess survey of the AI projects that are ongoing. And then this one now is on the needs of NOAA staff with regards to training. So what was the bottom line? We urgently need NOAA AI success stories converted to interactive learning materials. You may have heard of Python and Jupyter notebooks. This is not a heavy lift. We like to coin the term or use the term learning journeys. Think of if you have several notebooks that kind of stitch together a story of machine learning exploration in a particular topic, then that's kind of a journey through that topic. And so what's the motivation for needing these things? Without strategic coordination, we're not going to be able to train the workforce on building trustworthy AI applications. There's concern that applications that should be accelerated from their research posture all the way to operations across the so-called valley of death won't happen. It needs to happen with metrics, of course. And that would be a concerning waste of developmental resources if things like that get stuck. Other applications could get deployed without being trustworthy in a standard way. And agencies like ourselves could run significant risk of accidental or purposeful irresponsible use by other parties, which we don't want to see happen. And I just want to pay mention to a new paper that I read recently by Amy McGovern of AI2ES and her colleagues on a summary of what could go wrong. It's a wonderful paper. Well, it's a wonderful paper summarizing the kinds of things that could go wrong and how we can avoid those things. Okay, so, all right, a flexible training framework driven by open science. We're advocates, strong advocates, all of us here probably, for open science, ensuring trust is built into the AI application life cycle from the onset. This is the house. It looks like a house, right? That's with intention. This requires a diversity, integrated community of practice across the stakeholders. It requires open languages and tools such as Jupyter notebooks, Python, R, and platforms for exploration, perhaps like Collaboratory and Binder. There's others. And in combination, these are the foundational pillars for creating a co-productive enterprise development environment, and thus a flexible training framework driven by open science. There's, of course, also room for leveraging industry tools that are out there too. So what have we been doing? We have developed an initial framework and tools to modularize learning. We're looking eagerly, as always, to partner and coordinate. This, we believe, will work very well for modern learning paradigms, where interested parties can discover modules matching their needs to aggregate together into learning journeys. If you step back, aren't we all really kind of students when we want to learn something new, no matter what our career status is? I think so. So then take a moment to consider the things you might like to learn and consider the question of what types of students are on your technical teams with that in mind. Even if you're a manager, you're, say, managing a team of AI specialists, you would probably be interested in learning about how to gain explainability and trust in the applications that are being developed, as well as manage the sustainment and longevity of those deployed into an application, perhaps operations. So beginners, for example, are anyone technical or managerial starting from initial principles, while intermediate users are those with basic knowledge seeking out advanced experiences. And advanced users are those well-versed and wanting to keep current with the latest practices, always sought after. Learning journeys to empower diverse learners. So Jupyter notebooks stitched together into a journey, as an example. We believe the best way to dissolve inequity in applications is to integrate diversity of experience across the roles in a collaborative and co-productive environment. The learning journey concept is designed to empower different role-based user profiles to develop AI proficiency, ensuring our managers understand lifecycle management, practitioners are knowledgeable in AI for domain applications, and research operations best practices, and our users can develop their trust in the process all along the way with their feedback folded in iteratively. Okay, so if you're interested in learning, how much time do you have to devote? If you're a developer, how long will it take a student to make it through your learning journey? There's a big difference in the needs of learners who have a few minutes to spare in their lunches and those who are able to dedicate a full day or week to discovering AI methods. So we have some tools for you we'd love to collaborate on. One is a Jupyter Notebook template and guidebook, as well as a readability assessment tool called Ratchet, and that stands for Readability Assessment Tool for Code that helps with effective training. Okay. Oh, there we go. All right, research applications and operations. These are our pilots. So we've made it through our initiatives in this summary here. And now we'll share with you a few pilots, and then we'll be open for questions. So the first one up, a pilot project on creating a tropical cyclone model training data set. Think about it this way. What's the challenge? AI-ready and accessible benchmark satellite datasets are needed to drive the future of tropical cyclone trajectory, intensity, and coastal impact prediction. Think about coastal flooding and other infrastructure damage. Think about the Hurricane Ida and its impacts along the coastline. Also have a wonderful, I think it's called a story map at NOAA, which I didn't link to here, but if you have an interest, please reach out and we'll give that to you. It's a really brilliant story that really hits close to home for a lot of people by bringing their voices into the conversation. The next project that we are piloting is to value NOAA's data with publications. So can machine learning help value our NOAA data investments by connecting research articles that have made it through the peer review process and the data referenced in those articles? This is exploratory and very promising. There are very promising early results. There are a lot of interested parties in this. For example, the Coleridge Institute, who's been leading the effort, NASA, USDA, NSF, Texas Supercomputing Center, Elsevier, many others. And the goal is to help researchers find data used in their research topic and improve understanding our data users and our return on investment. And the third and final project, pilot project for this year, with intention to expand these kinds of things into the next years. This one is towards fusing humidity and socioeconomic data or science. And think about this, the influence of humidity on human heat stress is an understudied mechanism. This is due in part to the lack of homogenized humidity data sets at a fine enough resolution at a US county level resolution and daily temporal resolution, which is necessary for coordinating analysis with public health data. So this project is basically looking towards the creation of a spatially complete surface humidity data set by blending remotely sensed and in situ surface humidity data using AI methods. And really just a wonderful project on in the direction of the eventual direction of having a fully homogenized humidity set to pair along temperature, for example, to empower heat exposure research topics, as heat exposure is a major form of a death around the world. All right, so on that, finishing up the summary of pilot projects, we'll move into partnership development. And without further ado, here is the flyer and save the date for our next AI workshop. It is the 4th workshop. It builds on the prior 3, originally hosted by NOAA NOSDA's STAR, and then hosted now by the NOAA Center for AI. And we thank NCAR in particular, including your very own Sue Hopt, for supporting the shaping of our upcoming workshop. So check out noaa.gov/AI, our website, to both express your interest in attending and participating. The themes are going to be, since they really text is a little bit small here, fire, weather, and impacts. So that group is, that theme will involve people who are interested in hacking on Jupyter notebooks with NOAA data for fire weather topics. The second theme is AI for ocean conservation, and thinking about what are the existing user interfaces and tools that are out there, and what kinds are needed by the community. And then the third is interoperable digital twins. This will leverage ultimately. So why do we need these to be interoperable? Because we can't put all features into every digital twin for Earth. And so ultimately this will leverage the best global capabilities, connecting physical and social and policy science and application, for example, for vulnerability and mitigation of climate change. This is open to the public. So we are working on topics of interest to the public and not just of interest to NOAA. And it is September 6th to 9. And now I'd like to show you a cool graphic summarizing our community of practice mailing list subscribees. So these, we have about 580, I think it's maybe 520 real, because we found there are some duplicates. But in any case, it's public. Again, you can get to it from the website, and you can share with a diverse group of persons there. And this, these members are from USG, academia, and industry, and they're looking to NOAA Center for AI to help facilitate conversations around infusing AI in climate, weather, ecosystem, and environmental justice. There are over 109 organizations represented, so please feel free to join and share the message if you know of others that might be interested. And here is my last slide. All right, different ways to engage. All right, so I've mentioned a bunch of different things. Our public access point is right there, noaa.gov/AI. We'll hopefully have some cool stickers to share in person for those at the July ESIP meeting. There's a link to joining our mailing list, so you don't have to hunt around for it. If you're inside NOAA's ecosystem, we also have something for people in NOAA. If you missed our 3rd workshop from last September, there's a link to the recordings. If you have an interest in upcoming events, there's the Summer School on Trustworthy AI for Environmental Science. That's June 27 to 30. As you know, it's organized by NCAR and NSF, their AI Institute for Research on Trustworthy AI in Weather, Climate, and Coastal Oceanography, AI2ES. And we, the NOAA Center for AI, is a partner. Then there's ESIP in mid-July, so July 19 to 22. That is both predominantly intended to be an in-person meeting, but I believe we'll have some virtual components to it. And it's going to be a hands-on, we are going to host a hands-on session. So there's a link so you can check out opportunities to join that meeting if you're interested. Our upcoming workshop, again, is September 6 to 9, later in the summer. Again, the 3 topics: fire weather, ocean conservation, and interoperable digital twin Earth. You can express your interest at our website. And then there's the zoo of past events and a few links to talks that you might be interested if you missed those. I believe most of them probably are recorded or have materials, or you can reach out and we can help you with that. So finally, thank you so much for your time. I hope you enjoyed a rather brief journey with us. Looking forward to engaging with you now or at an upcoming meeting. And you've got a few ways that you can connect with us if you look forward to it. And I forgot to mention the ESIP meeting is data for all people. So we're very excited about that. Thank you.
Great. Thank you, Rob. It's good. I'm very glad to see that NOAA is engaging, very heavily in this area. I don't think it was even at all on the horizon when I left NOAA in 2018, and all of a sudden here we are. So looks like we do have a few questions here, and I would encourage people to submit more. And once questions are submitted, as you know, you can upvote them if you're interested in somebody else's question. So let's see, Rob, I don't know if you see this on your screen, but in any case, I will read them out. Brian Bonlander asks, I see many of the objectives for AIReady as being closely aligned with statistical analysis ready. Opening collaboration to earth scientists who regularly perform statistical analysis on big data rather than just those who work with AI algorithms could be very useful. So it's more of a question, more of a comment than a question, but feel free to elaborate on that.
Thank you. Yeah, I'll just say 100% agree. A lot of the things in our AIReady list of important features are important for any stewardship, important for FAIR principles, findable, accessible, interoperable, usable, and important for data science in general. So I couldn't agree more. Thank you, Brian. Would you like me to just go through the questions as I see them here, or would you like to do that?
I think I've been doing it. That's been our practice, for better or worse.
Thank you. Thank you.
So next question was submitted by some guy named Jeff with an incredibly long last name. And it's, will NOAA issue any AI-focused requests for proposals where people can apply for funding?
That is an intention in a hopefully future fully funded resource scenario for NCAI. There are also lots of opportunities already that aren't coordinated this way. So there's the HPCC. If you're already an affiliate with NOAA, you're already working with NOAA persons, there are some existing opportunities already. But yeah, I think the ultimate dream is to be able to do more to help coordinate advances in NOAA's mission, and I see RFPs as an excellent process for that. I don't have any specific ones to share about today, though. But thank you for the question.
Yeah, fair enough. We're often constrained less by interest and more by, who to charge, what to charge to. Let's see.
Fair enough.
Christopher Wirtz asks, you mentioned trust and trustworthy AI several times. What does that mean to you and or your group? Oh,
yes, it's a great question. I think I lost the questions there, but that's okay. So it means a lot. It means a lot of things, right? It means do we say you're a developer? It means, do you have faith that you've explored enough of the possible solutions to your problem that your solution is sufficiently explainable that you trust it? You're the developer. You hand it to other developers. Do they have enough insight into the black box aspects of a lot of machine learning models that they also have sufficient understanding of why it's predicting what it's predicting? And then if you keep moving, maybe all the way to the end users, how do we ensure that end users who aren't familiar perhaps with the science behind this, the observations that were used, the modeling techniques, but they're of course the most vested in the use of the results? How will those results impact, say, policy decisions? So that's that trust cascades all the way to those with a stake in equity. I personally think that there's a lot of great publications out there on explainable AI. A recent one was by Amy McGovern and colleagues, and there's a lot of references in there as well. I actually have a whole slide on this. If we have time, I can kind of go to it, but I hope that addresses initially the question. I saw there were several other questions too.
Yeah, can we get the questions back on screen?
Oh, thank you.
There we go. Okay, thank you. Yeah. So Philip asks, as a rising senior starting research in deep learning applications to climate data, are most of these opportunities / seminars that you mentioned open to students to participate in? And Rob, just so you understand, we have a student internship program, very successful here, the SciParks program. Yeah. So this gentleman is part of that.
Yes. Yeah, that's wonderful. Well, congratulations for being part of an excellent program already. So we are starting to work with NOAA's Office of Education on infusing topics, basically infusing kind of some of the core facets of what we think will be very helpful in AI application development into opportunities that are already being cultivated by PIs within NOAA. So check out the Office of Education. There we should start to see language that adds AIReady and learning journeys and Jupyter notebooks. Also, feel free to reach out to us. I'm happy to let you know if we hear of any new opportunities. So when you say our most seminars are definitely open. Opportunities, I think, check out the Office of Education and also contact us. That's probably a good way to learn more there. We're kind of just getting started on that topic. We're trying to make as many connections as we can. There are also some starting point connections being made with HBSCUs and other minority serving institutions. But we are just kind of getting started on this. So love to hear more perspectives on how to make progress in these areas. On the area of education, especially education with early career interested parties. Thank you.
Yeah, great question. Katie asks, thanks, Rob, for the great talk. Can you say more about what a digital twin means to NOAA Center for AI and how it differs from past modeling efforts?
Yeah, I'm glad you asked about this because there's so much terrain there. I'm not an expert on digital twins, but I'm learning quite a bit lately because we are going to conduct an interoperability theme, right? So this is a great question, and it comes up a lot. Think about often modeling efforts are that they are focused on specific modeling problems and challenges. The way I see a digital twin for Earth to be, I see it more to be something like that collection of models, and possibly if they're physics-based models and maybe they're resource hungry and also take a long time to run, could also be the collection of machine learning emulation and simulation to allow scientists and allow possibly down the road policymakers to run scenarios, and those scenarios could be thinking about adaptation and mitigation and other ways to improve things in a changing climate, and do so in a way that has social equity in mind, so that we're all benefiting from positive outcomes in our environment. So it's more than one or even a few modeling efforts. It's kind of that collection of modeling the whole Earth system, being able to do it very, very quickly, and being able to pair it with social science as well, so that scenarios can be explored. Destination Earth is there's lots of digital twin investments and developments ongoing. I'd encourage you to check out Destination Earth. That's just an example. That's the European Union's investment in this area. And also, you can send me an email. I'm happy to send you some additional references and details that you might be interested in.
Great, thank you, Rob. So I'm actually going to pair this question from Eric with mine because they actually touch on similar things. Eric says, great talk. Thank you. What would be the most impactful changes current scientific data repositories could make to support AI-ready data? And then the sub-question, which is kind of expressed in mine at the bottom, was the problem that we're an archive. People submitted data to us. We don't necessarily have permission to go back and modify their data to make it somehow more AI ready. So things that we could do outside the actual data, like more metadata or more access services, would be easiest to implement than going back and trying to analyze all their data to, mark features or whatever.
Wow, yes. That's a lot. That's a really excellent question. It deserves a greater exploration than I can do justice in real time. I'm going to give it a stab. So, right, there's several things here in terms of what you already hold in your archive and how you might be able to have a hand in the curation process for data that are inbound to benefit future uses. We have same problems at NOAA, of course, and same challenges, I should say. Because the challenge, there's always opportunity. So I think the most impactful changes are to think about what metadata is unstructured and could be more structurized. Maybe you can't do it at the granular level because that's already provided and it's owned and you don't want to mess with the provenance, but perhaps you can do it as a sidecar file and sidecar information to get to machine actionable information. I do think engaging in what does it mean to be AI ready? And as a previous questioner provoked, there are others. There's analysis ready data. There's fair ML. There are prior efforts to think about what you need for sophisticated statistical analyses. To get involved in these efforts, we are looking to not go this alone. So I think that's an impactful change. Make sure your industry, your agency, your research community is represented in the process so that UCIB data readiness cluster is a good place to go. There's a lot of activity. So I think that's an impactful change. And I also think I'm a big fan of just trying things. So as new data sets are being explored, seeing if we can get involved to recommend good best practices to serve these future needs. I sort of mentioned that with the idea, we have a huge archive of data with probably, by today's standards, unstructured metadata, by the standards of the time, exactly what we needed. And now we would like to be able to harness that information in an automated way. So, and you mentioned feature detection. I would argue that projects that leverage data, and then, so think about like DOI connecting, that's actually a major, a major impact also could be making sure every data set has a DOI. And we don't have that yet. Some do. And making sure those DOIs have kind of a life history to them when they're updated over time. And they have code and sample notebooks next to them and labeled features next to them if they've been used in such a way. And one more thing I mentioned is if said data sets have been used in peer-reviewed machine learning model development, then maybe some of those model outcomes might be considered benchmark models using those data sets. So that when you're advancing another technique, you have a benchmark to compare to model and data-wise. I'm just exploring a few ideas there. I think there's a lot more to be thought about there. Yeah, but I appreciate the question and opportunity.
Well, and that's an area, we're in town, so maybe we can actually have some discussions and figure some of this out. Yeah, and we are coming to the end of the time, so let me ask John's question. I think you mentioned you were going to share a link for your slides. Is that possible? Thanks for your talk.
100%. Yes, we'll share a link to the slides, and I'll do my best to make sure that movies are embedded into it too.
Oh, great. Oh, great. Yeah, and hopefully we can actually publish the video of this. So I'm going to squeeze in this last one. You mentioned that automated detection of fish in the undersea video. No, it used to have some kind of crowdsourcing things where they had humans actually looking for those things. Is that obsolete now, where AI does it for us and we're good?
No, I wish I'm not an expert here, but I think it's not obsolete, but
Okay.
some of it's been automated.
Okay.
I could get back to you on that. Let
Yeah,
me do a
just,
little exploring in the fisheries side of things. We always need to have humans as part of the vetting, but to what degree they are they 100% of the solution or 5% of the solution at this point? I'm not sure. We're always trying to move the needle over to automating the work and having humans validate the process.
Yeah.
And teach the system about new species. So that is an area where definitely humans have to be. AI is not going to replace humans. Hopefully it's going to empower them.
Yes. Well, Rob, we're at the top of the hour. Thank you very much for your talk. I'm sorry we can't do these in person yet, because I think it's much more, or even like if we were all on Zoom instead of having the audience, hidden away on the streaming thing, even that I think would be a little bit better for a nice discussion. But this was very good. I truly hope that we can collaborate with NOAA on this, somehow. In my case of our division, making our data ready, but there's other people in NCAR, I think, who do actual AI work can help. So thanks again, and I think we're gonna end here.
Thank you.